Hi, everyone. Welcome. Thank you for joining us for this special AI Week track for deep learning for tabular data. First, I want to thank PayPal and AI Week teams that worked very hard to make this happen. And I also want to thank the presenters we are going to hear today. I will introduce myself in a few minutes, but before, let me introduce you to one question of why we are here. Why did we choose specifically this topic of deep learning for tabular data to be the topic of our special track? One of the answers relates to something I learned while working at PayPal. And this is about the deep learning for tabular data is actually a specific case of much broader discussion about when innovation meets practice. And by that, I mean how we can take existing tools and find new ways to use them to solve other challenges. Let me give you more context by introducing PayPal and myself. PayPal has been leading the payment space for over 20 years with a variety of products such as checkout, from peer-to-peer payments to QR codes, from donation programs to credit installments and credit lending. I think it is fair to say that PayPal is not just a payment method, it has become a holistic solution for consumers and businesses, small or large, when it comes to their financial transactions. We operate in huge scales. We have hundreds of millions of customers in more than 200 markets. And for that, we use technology, big data, machine learning, first to support our customers and ensure they get fast, safe, and secure experience, and also to scale up and innovate. We use tons of tabular data, but not only. We also model our data sets as graphs and networks and take advantage of large NLP textual data sets. What's exciting is that data science and machine learning are really at the core of PayPal products and real-time systems with applications such as fraud risk, credit, and marketing. To do all of that, we have a dedicated data science organization and teams across the world. Here in Tel Aviv, we have dozens of data scientists working in multiple teams, each with a slightly different focus. And together we form a data science community, which is one of the best things to have for me as a worker at PayPal Israel. Together we share knowledge, we brainstorm, we read papers, we even host an internal data science podcast and support each other when we prepare external talks like this one. And please feel free to reach out if you find this interesting or check out our careers website. I joined PayPal around 3 years ago and worked on fraud detection models and ways to debug them using explainable AI. Last year, I joined PayPal AI long-term research team, where I study causal inference and causal machine learning applications to PayPal business cases. This means dealing on a daily basis with how to connect innovation with practice. Going back to our topic of the session today, the first POC to apply deep learning for tabular data was done in this research team several years ago. And since then, many machine learning teams across PayPal adopted and expanded this practice and are constantly releasing to production successful deep learning models for tabular data. How about you? I wish we could do this in person, but let's try to raise your hands up anyway. How many of you work with tabular data? I assume many hands up because this two-dimensional table with rows of samples and features as columns are super prevalent in almost every real-life case around us. How many of you applied deep learning to tabular data? Now I assume less hands up because we cannot ignore this elephant in the room, which are tree-based models. Tree-based models work great for tabular data. You usually need to put much less effort and get great results. And they have become the first go-to when you have tabular data to model. However, other data types do have deep learning queens. You may be familiar with RNNs and transformers for textual data, or with CNNs to model image data. For tabular data, we don't have such queen yet. And a very interesting question to ask is why? I'm sorry that I cannot answer this question right now, because this is still an open, wide, and ongoing discussion. On the one hand, specialized architectures for tabular data are being constantly published. On the other hand, comparing these architectures with simple neural networks or with tree-based models show that the picture is complex. I'm very happy today to have with us a few authors of these papers to share more about their work. In addition to the academic discussion, I also want to highlight two advantages we practically found at PayPal for using deep learning with tabular data. One is around neural representation learning. Having a good neural representation of your tabular data opens up worlds of unsupervised learning, transfer learning, and generative modeling. Yarden, who is being a speaker right after me, will describe much more about that. I also want to highlight the creativity and flexibility that neural network allow us as data scientists. What do I mean by flexibility? Think about tree-based models as this type of playground. You can play these instruments one by one, like tree-based models, a model per task. Switching to deep learning allows us to adjust the architecture to business knowledge, to maybe train a single model for several tasks and by that reduce maintenance. And we'll discuss much more practical aspects of using deep learning with tabular data in the panel discussion later on.